In this session, let us discuss the derivatives of hyperbolic functions. Hyperbolic functions. So, what is hyperbolic function? The equation e power x minus e power minus x divided by 2 is called hyperbolic sine function. Hyperbolic sine function, or it is also called arc sine function. Arc sine function. That is sine hx. Hyperbolic sine x. It is read as what? Hyperbolic sine x. Sine hx. Sine hx means what? Sine hx means hyperbolic sine function, or it is arc of sine function. Sine hx is equal to e to the power of x minus e to the power of minus x divided by 2. Similarly, we can also define cos hx. Hyperbolic cosine function. Hyperbolic cosine function is e power x plus e power minus x divided by 2. Tan hx. Tan hx is equal to, what is sine tan? Tan is what? Tan theta is sine theta by cos theta, correct? Here also it is sine hx by cos hx. This 2 to get cancelled. It is e power x minus e power minus x divided by e power x plus e power minus x. Tan hx is e power x minus e power minus x divided by e power x plus e power minus x. Cot hx. Cot hx is equal to, it is reciprocal of tan, or cos divided by sine. It is e power x plus e power minus x all divided by e power x minus e power minus x. Cosecant hx. Cosecant hx. Cosecant hx is reciprocal of this. It is nothing but what? 2 divided by e power x minus e power minus x. Secant hx. Secant hx. Hyperbolic secant function. It is reciprocal of cos hx. It is equal to what? 2 divided by e power x plus e power minus x. So these are said to be hyperbolic function. Sin hx, cos hx, tan hx, cot hx, cosecant hx, and secant hx. All these functions are called what? Hyperbolic trigonometric functions, right? Hyperbolic trigonometric functions. Let us derive the derivative of these hyperbolic functions. What is differentiation of sin hx? What is differentiation of cos hx? What is derivatives of tan, cot, secant, and cosecant? So just remember, this is called what? Hyperbolic function. The hyperbolic functions are always be expressed. Hyperbolic functions are always be expressed in terms of exponential function. Exponential function. What is exponential function? E. Exponential function, right? Let us take the derivative of hyperbolic function. What is derivative of sin hx? What is derivative of cos hx? Like that. Derivatives of hyperbolic functions. Let y is equal to sin hx. What is sin hx? Sin hx is nothing but e to the power of x minus e to the power of minus x divided by 2. Correct? Differentiate y with respect to x. we get dy by dx is equal to differentiation of this function. What is this function? E power x minus e power minus x divided by 2. 2 is what? Constant. Take it outside or keep it as it is. Keep the constant as it is and differentiate the function. What is differentiation of e power x? Differentiation of e power x is e power x minus. What is differentiation of e power minus x? E power minus x, it is considered as what? Function. E power function. Sorry. E power function. What is derivative of e power function? It is e power function into d by dx of function, correct? Differentiation of e power x is e power x. This is treated as childhood e power function. It is e power function into d by dx of function. What is function? Minus it is equal to 1 by e to the power of minus x into differentiation of minus x is what? Minus, or it is 1 by 2 into e power x minus into minus plus e power minus x. So it becomes what? E power x plus e power minus x divided by 2. What is it? It is nothing but cos hx. It is nothing but cos hx. So d by dx of sin hx is equal to cos hx. So similar to this, we can differentiate for all the hyperbolic functions, right? This is the procedure. You need to follow this procedure to get the derivative of hyperbolic function. So derivation is not necessary. You just remember the derivatives of the hyperbolic functions. How to get the derivatives? This is the procedure. Okay, I have given for sin hx. You can follow this for other hyperbolic functions. Definitely you will get this list. So I will make you list of derivatives of hyperbolic functions. See, d by dx of sin hx is equal to cos hx. D by dx of cos hx is equal to sin hx. D by dx of tan hx. D by dx of tan hx is equal to secant h square x. D by dx of cot hx is equal to minus cosecant h square x. Cosecant hyperbolic square x. D by dx of secant hx is equal to minus of secant hx into tan hx. D by dx of cosecant hx is equal to minus of cosecant hx into cot hx. These are the derivatives of hyperbolic functions. For sin hx, it is cos hx. For cos hx, it is sin hx, not minus sin hx. So we already learned that differentiation of cos x is what? Cos x differentiation is minus sin x. But here, minus will not be here, right? For sin, cos. For cos, it is sin. Other things are same. Other things are similar to trigonometric function except these two. For trigonometric function, differentiation of cos x is what? That is sin x. Differentiation of secant x is what? Secant x into tan x. But here we have minus of secant hx into tan hx. For cos hx, it is not the minus, it is plus sin hx. Right? Only these two difference when compared to trigonometric function and hyperbolic functions. Okay. Using these derivatives, we can use them in the problems of differentiation. So far we have learned the derivatives of ordinary functions and we have applied the rules of differentiation and we have used the chain rule, correct? And inverse trigonometric functions. So for all the types, we should extend the same procedure for hyperbolic functions. Rules of differentiation and chain rule is also applicable for these hyperbolic functions. Let us work out few problems. Differentiate the following. Differentiate the following with respect to x. Differentiate the following with respect to x. Y is equal to sin hx minus x square plus cot hx minus 5. How it is? It is of what? The given function is sum or difference of many functions. Okay, then we should use sum or difference rule. What is sum or difference rule? We have to differentiate individually. Differentiation of sin hx minus differentiation of x square plus differentiation of cot hx, differentiation of constant, right? Differentiating the given function, we get differentiation of sin hx is what? Cos hx minus differentiation of x square is what? 2x plus differentiation of cot hx is equal to minus cosecant h square x minus differentiation of 5 is what? 0. So finally you will get cos hx minus 2x plus into minus minus cosecant h square x. So we can combine the hyperbolic function as well as the trigonometric or algebraic functions. Y is equal to 3 divided by sin x plus 2 tan hx minus 4 x cube plus 5 to the power of minus x plus 10. It is a combination of the ordinary terms as well as hyperbolic terms and trigonometric and algebraic combination. Okay. What is differentiation of 3 by sin x? See, it is appearing what? Sum or difference of 5 functions. This function plus this minus this, like that. Can you differentiate this directly? No, we will not able to differentiate this because it is at the denominator. So what you can do? You can take this as 1 by sin is what? 1 by sin is cosecant x, correct? If any trigonometric ratio like this at the denominator, you should take its reciprocal. There itself you should not differentiate. Okay, so 1 by sin, treat this as 1 by sin whose differentiation is, sorry, whose answer is what? 1 by sin x is equal to cosecant x plus 2 tan hx. I am not differentiating, I am just taking as it is. I am taking as it is, except this, it is simplified form I have taken here. Now I am going to differentiate with respect to x. Dy by dx is equal to 3 into differentiation of cosecant x. Differentiation of cosecant x is what? Minus cosecant x into cot x plus 2 into tan hx. Hyperbolic tan function. Differentiation of tan hx is secant h square x minus differentiation of 4x square, 4x cubed, 4 into 3 what? 4 3s are 12, x to the power of 2. Minus, again it is treated as what? A to the power of function. A to the power of function because of minus x. For a power minus x it is what? A power minus x into log a, correct? What is a? A is 5 into d by dx of minus x plus differentiation of any constant is 0, right? So it is finally minus 3 into cosecant x into cot x plus 2 secant h square x minus 12x square minus 5 to the power of minus x into log 5. Differentiation of minus x is what? Minus 1. You can take directly this minus 2 here, it becomes plus and this will become cancel. So this is the answer, right? So here we have used in sum or difference rule, correct? Let us take in the product and quotient form. Y is equal to e power 2x into sine of h 3x, or just take it as it's x. What is problem? Problem is y is equal to e power 2x into sine hx. It is combination of exponential function and hyperbolic function. It is in what form? It is in product form, correct? Take this as u into v. What is u? It is e power 2x. What is v? Sin x. Use product rule. Differentiation of product of two function is what? U into dv by dx plus v into du by dx, correct? Just write according to that formula. Dy by dx is equal to e power 2x into d by dx of what? Sin hx plus sin hx into d by dx of what? E power 2x. I have written according to product rule. Okay. Next, wherever we have d by dx, you just differentiate it. E to the power of 2x. Differentiation of sin hx is cos hx plus sin hx into differentiation of e power function. What is differentiation of e power function? It is e power function into d by dx of 2x. That is e power 2x into cos hx plus sin hx into differentiation of 2x. Differentiation of 2x is 2 into 1. If you want to further simplification, what you can do? You can take e power 2x as common. E power 2x into cos hx plus 2 into sin hx. This is product of two functions. Next one, y is equal to 7x plus 3 into secant hx dy by dx is equal to what? Take this as u into v. According to the rule, u, keep u as it is, differentiate v, plus keep v as it is into differentiate u. What is u? 7x plus 3. That is equal to 7x plus 3 into differentiation of secant hx. That is what? Minus secant hx into tan hx. Is it right? See the list. For secant hx, it is minus of secant hx into tan hx plus secant hx into differentiation of 7x 1 for 3, it is 0. Okay, you can write like this, or if you want, you can multiply this minus of 7x plus 3 into secant hx tan hx plus 7 into secant hx. you want, you can take secant hx as common. Okay. Y is equal to sin h 5x divided by 1 plus x square. It is of what form? It is in the quotient form, correct? U by v. U by v. What is u? Sin h 5x. What is v? It is 1 plus x square. What the quotient rule states? It is v into du by dx minus u into dv by dx all divided by v square. All divided by v square. You just write according to that rule. What is v? 1 plus x square. What is u? Sin of h 5x. dy by dx is equal to 1 plus x square into d by dx of sin h 5x minus sin h 5x into d by dx of what? 1 plus x square whole divided by 1 plus x square whole square. We have written just according to the quotient rule, right?
We are not getting
Keep
video.
1 plus x square as it is. This has to be differentiated. Okay, differentiation of sine hyperbolic function cos h 5x into dy dx of what? Dy dx of 5x. Why we are taking like this? Because it is function of a function. Sin h of 5x. 5x is treated as what? It is function. Minus, keep this as it is. Sin h 5x into differentiation of 1, 0 plus for x square. It is 2x. Whole divided by 1 plus x square whole square. Next step, what is differentiation of 5x? 5 into 1. I am taking here that 5. 5 into 1 plus x square into cos h 5x minus 0 plus 2x is what? 2x. Just take it here. 2x into sin h 5x whole divided by 1 plus x square whole square. This is answer. Got it? Let us take 1 or 2 problems of chain rule. So we have applied in the above problems. Y is equal to cos of sin hx minus cos hx divided by 2. Find dy by dx. See this problem, it is cos of function, correct? We have to treat this as cos of function. What is differentiation of cos function? It is minus sin function into d by dx of function. It is treated as what? Cos of function. So dy by dx is equal to differentiation of cos x is what? Minus sin x. But here in place of x we have a function. Minus sin of function. Sin hx minus cos hx divided by 2 into d by dx of what? Sin hx minus cos hx by 2. So this will be as it is, right? Minus sin of sin hx minus cos hx all divided by 2 into differentiating this. Differentiation, take 1 by 2 as it is. 1 by 2. Differentiation of sin hx is what? Cos hx. Minus differentiation of cos hx is what? Sin hx. Just check the answer. Any simplification is possible? No, just keep as it is. This is chain rule. Y is equal to root of log of sin hx plus cos hx. So this is root of function into log of function. Root of log of function, correct? This is read as root of function. Root of function. What is derivative of root function? What is derivative of root function? It is 1 divided by 2 root of log of sin hx plus cos hx into what? Root x get differentiation 1 by 2 root x, right? For root function, it is 1 by 2 root function into d by dx of function. D by dx of function, that is log of sin hx plus cos hx. Keep the first term as it is, 2 root of log of sin hx plus cos hx into. It is treated as what? Log x. It is similar to log x, but we have to use chain rule. Treating log of function. For log function, it is 1 by function. 1 by function into d by dx of function. Right? This is equal to 1 divided by 2 root of log of sin hx plus cos hx into, this will remain as it is, 1 by sin hx plus cos hx into, what is differentiation of sin hx? It is cos hx plus differentiation of cos hx is sin hx. Observe here, these two are same. Sin hx plus cos hx or cos hx plus sin hx, they get cancelled. Finally, what is remaining? It is 1 divided by 2 root of log of sin hx plus cos hx. Correct? It is 1 divided by 2 root of log of sin hx plus cos hx. This is the final answer. Like that, the same procedure of product rule, quotient rule, function of a function are all applicable for these hyperbolic functions, right? The next stage, let us take the other type of differentiation. Implicit function. Implicit functions and their derivatives. Implicit functions and their derivatives. Let us know what is implicit function. So far, we have taken such functions. Y is equal to f of x, correct? Here, x will be given separately. Y is expressed in f of x, correct? It is, I will call it as explicit function. Why? X terms are at the right side, y term will be at the left side. Such functions we have derived, we have differentiated so far, right? Now, the function, if it is in this form, x term as well as y term are combinedly given. X and y variables are in mixed form. Such functions will be called as implicit function. This is called what? Implicit means implicit function. Both x and y will be included in a given function, right? Such functions are called what? Implicit function. Example, we can say the functions of the form f of x comma y is equal to 0. X, y may be in sum or difference or product or in the quotient form. You may have more than one y or x like that. Is called are called implicit functions. Implicit functions. See the example. Y is equal to sine of x plus y. Here y is equal to sine of x plus y. It is given in y only, but see the right side, it is in which form? X as well as y is in some form. Okay, it is said to be what? Implicit function. So this simple example, x square plus y square is equal to a square. X square plus y square. Only y is not there. It is in what? Y square. Root x minus root y is equal to root a. X sin x plus y sin y is equal to 0. Log x plus log y is equal to 0. Tan of x plus y minus tan of x minus y is equal to 0. E to the power of x plus y is equal to x square plus y square. Root of x plus root of y is equal to root of xy. So they are all example for implicit function. Observe all the examples. They are in which form? They are in the equation form, but x and y, their position is not confirmed. They are at any position. X, y, they are in the sum form, difference form, in the product form, or in the sides form. Okay, it may be in any form. So such functions are treated as what? They are treated as implicit function. For all find out dy by dx. Suppose if it is in x and y. Okay. How to get dy by dx? See, if I take this equation, I need to differentiate on both sides. I have to differentiate on both sides. How to differentiate this? This is treated as e to the power of function. Okay, e power function into d by dx of function. Differentiate these two. What is differentiation of x square? It is 2x. What is differentiation of y square? We don't know. But the x term and y term are differentiated similarly. On differentiating, if you come across y term, it is differentiated similar to x term, but at the end we have to write dy by dx. That is the procedure. Okay, I will show you the difference of writing derivatives of x term as well as y term. If you remember this difference, it is easy to get the dy by dx. Difference in derivatives of x and y terms. Suppose if we have a x, what is differentiation? 1. Suppose if we have a y, what is differentiation? It is 1 into dy by dx, or we can simply take it as dy by dx. Right? For x, it is 1. For y, we have to take it as dy by dx. For x square, it is 2x. For y square, it is differentiated similar to x. Then it becomes what? 2y. But it is y term now. At the end, we have to write dy by dx. Like that, every y term has to be differentiated similar to x term. But at the end, we have to write dy by dx. See, for log x, it is 1 by x. For log y, it is 1 by y into dy by dx. For e power x, it is e power x only. For e power y, we have to take e power y into dy by dx. For sin x, differentiation of sin x is what? Differentiation of sin x is cos x. Similarly, for differentiation of sin y, what is the answer? Differentiation of sin y is cos y into dy by dx. Cos y into dy by dx. Okay. For sin inverse x, we will take it as 1 by root of 1 minus x square. For sin inverse y, what to take? It is taken as 1 by root of 1 minus y square into dy by dx. I think you got the difference of taking derivatives of x term and y term. Suppose if x term and y term or x term, if they are in the product form xy, you have to use product rule. See, xy, x sin y tan x, y secant y, like that. For all these things, we have to use what? Product form. Or if x and y term are in the quotient form, we have to use quotient rule. Okay. To get the differentiation, first thing, we have to differentiate every term. While differentiating, if you have x term as well as y term, you differentiate it separately. Differentiate x term. We know the differentiation of x term. Y term, it has to be differentiated similar to x term, but at the end we have to write dy by dx. See, according to that. After that, separate all dy by dx term to one side, others to other side. Take dy by dx and finally you write it for dy by dx. That is the procedure of getting dy by dx in implicit function. Example. For the following functions, find dy by dx. The first function, x square plus y square is equal to a square. What is function? Function is x square plus y square is equal to a square. The given function is differentiated on both sides. Differentiate with respect to x on both sides. Then, for such function, don't start dy by dx is equal to. Why? So it is not given in y is equal to f of x form. For such function, we have to start with dy by dx. But it is what? It is of what? It is of x comma y is equal to 0 form. For all the functions of this form, don't start with dy by dx is equal to. Okay, then what to do? You take each term Consider each term, differentiate them. Differentiation of x square to x. Say I am not written any is equal to symbol or dy by dx here. Just I am plainly differentiating each term. Wherever you have is equal to symbol, you just write it, carry it. Okay. For x square, it is 2x. For y square, it is 2y into dy by dx is equal to a square. A is constant. Differentiation of constant is 0. See, differentiation part is over. Next, what to do? We have to simplify for dy by dx. Means take dy by dx term at left side. Keep the dy by dx term at left side. And the term which do not have dy by dx, that has to be taken to other side. It becomes what? Minus 2x. Then write for dy by dx. Dy by dx is what? Minus 2x divided by 2y. 2 to get cancelled. The answer is minus of x divided by y. Next problem. Root x minus root y is equal to root a. The problem is of what form? It is f of x comma y is equal to 0 form, right? Differentiate on both sides. Differentiate on both sides with respect to x. We get what we get? We get derivative of root x is what? 1 by 2 root x minus derivative of root y. Differentiate root y similar to root x. That is 1 by 2 root y. But we have to write dy by dx at end is equal to differentiation of constant is 0. Now keep the dy by dx term at left side and take the other term to right side. That is 1 by 2 root of x. Therefore, dy by dx is equal to what? Dy by dx is equal to, first write the right hand side term, minus 1 by 2 root x divided by, take this to denominator. So it is minus 1 by 2 root y. Correct? Whatever the product of dy by dx, that has to be shifted to denominator of other side. This two cancel. Finally, minus minus cancel. 1 by root x into 1 by root y. If I make into or product, it becomes what? Root y divided by 1. Finally, it is root of y divided by x is answer. Dy by dx is equal to what? Root y divided by root x. You can write it as root of y by x. This is known as implicit function differentiation. Let us take some more important problem. If y is equal to, or you can take x square plus y square, x square plus y square, or x cube plus y cube minus 5xy is equal to 0. Next problem is what? X cube plus y cube is equal minus 5xy is equal to 0. It is in the equation form, implicit form. Differentiate on both sides. Differentiation of x cube is what? 3x square plus symbol. Differentiation of y cube is what? 3y square into dy by dx minus, what is next term? 5xy. How to differentiate it? Don't say 5 into 1 into dy by dx, because it is in the product form. Correct? This is in the product form. 5 into x into y. When there is into or product, we have to go for product rule. Take this 5x as u and y as v. take 5x as u, y as v. Because of minus sign, you put a bracket. Otherwise, it is not necessary. What the product rule says, u into d by dx of what? V. V is what? Y. Plus y into d by dx of what? 5x is equal to 0. If x into y is there, you should use product rule. Then 3x square plus 3y square into dy by dx, multiply with minus sign, minus into plus minus 5x into dy by dx. For y, derivative is dy by dx. Multiply with minus sign, minus into plus minus y into differentiation of 5x. 5 into, for x it is 1, is equal to 0. Then we need to retain dy by dx term at left side, and we have to shift other terms to right side. 3y square dy by dx minus 5x into dy by dx is equal to what? Here we don't have dy by dx, you just transfer it. What happens? Its sign changes, 3x square. Then here is dy by dx, we have taken, this is also taken. Is this one? We don't have dy by dx, it has to be transferred, right? Minus 5 into 1 into y, 5y, it become plus 5y. So after collecting all dy by dx term to left side and the others to right side, take dy by dx common at left side. Dy by dx is common. What is remaining? 3y square minus 5x is equal to minus 3x square plus 5y. Finally, you write dy by dx is equal to what? First write the right side term, that is minus 3x square plus 5y divided by the product form. This factor has to be taken to denominator of right side. 3y square minus 5x. So dy by dx is what? 3x minus 3x square plus 5y divided by 3y square minus 5x. Sin x plus sin y is equal to k. Next problem is sin x plus sin y is equal to k. Differentiate on both sides. What you will get? Differentiation of sin x is cos x plus differentiation of sin y is what? Cos y into dy by dx is equal to k. K is constant whose derivative is 0. Right? Keep the dy by dx term at left side and take other to right side. It becomes what? Minus cos x. Finally, dy by dx become what? Minus cos x divided by cos of y. They are different. Cos x is different with cos y. They cannot be cancelled. Keep it as it is. Next problem. X square minus y square plus 3x minus 5y plus x square y minus xy square is equal to 0. Find dy by dx at 2, 1. For the given implicit function, we have to find dy by dx at 2, 1. It means after getting dy by dx, put x is equal to 2 and y is equal to 1. First get the dy by dx. differentiate the entire equation with respect to x. Differentiating with respect to x, we get differentiation of x square is 2x. Differentiation of y square is 2y into dy by dx because of y term. Plus differentiation of 3x. 3 into differentiation of x is 1. Minus 5 into differentiation of y is what? Dy by dx. Plus differentiation of x square y. X square y. How it is? It is of u into v form. Correct? X square into y. Take x square as u, y as v. X square into d by dx of y plus y into d by dx of x square plus or minus. It is minus. Again, how it is to be differentiated? X into y square. It is also differentiated by using product rule. Because of minus sign, put bracket. Take this is u, this is v. Product of x and y term. X into d by dx of what? Y square. Plus y square into d by dx of what? X is equal to 0. Then keep this 2x minus 2y dy by dx plus 3 minus 5 dy by dx plus x square into dy by dx y square. Now differentiate this. Differentiation of y is dy by dx, correct? Then differentiation of x square is what? 2x minus x into, for y square it is 2y into dy by dx, correct? For y square it is 2y into dy by dx. Minus into plus minus y square into differentiation of x is what? 1. So differentiation is over. Now we have to collect all dy by dx. I am underlining all dy by dx term. In all the 4 dy by dx term, I am taking dy by dx common. Here, if I take dy by dx is common, what is remaining? Minus 2y. Here, minus 5. Here, plus x square. Here, minus 2xy. Minus 2xy. And write all other terms to right side of equation. This is not having dy by dx. You take it to the right side, it become what? Minus 2x. This is not having dy by dx. Take it to the right side, it become plus 3 become minus 3. And this become what? Minus 2xy plus y square. Got it? Then you simplify for dy by dx. So dy by dx become what? First write the right side term. Minus 2x minus 3 minus 2xy plus y square all divided by, write this one, minus 2y minus 5 plus x square minus 2xy. We don't have common term to cancel. Therefore, substitute the given point. What is the point? 2, 1. It means x is 2, y is 1. Is equal to 2 minus 2 into x is what? 2 minus 3 minus 2 into y is 1 plus 1 square. Y is equal to 1 divided by minus 2 into y. Y is what? 1 minus 5 plus x square. X is what? 2 square minus 2 into x is 2, y is 1. That is equal to minus 4 minus 3 minus 4 plus 1 divided by minus 2 into 1 minus 2 minus 5 plus 2 square. 4 minus 2 into 1 4 minus 4 minus 3 minus 7 minus 4 minus 11 that is minus 10, divided by plus 4 minus 4 cancel, minus 2 minus 5, it is minus 7. So answer is what? 10 divided by 7. So if they ask dy by dx at a particular point, first you get dy by dx, then substitute the point by taking first is x, second one as y. Sine of x plus y minus sine of x minus y is equal to 0. Take the next different function of different form. See, sine of x plus y minus sine of x minus y is equal to 0. We need to differentiate both the terms. How to differentiate it? See the function. It is sine of function. For sin x, it is cos x. For sine of function, it is cos of function into d by dx of function. Correct? Differentiating, we get cos of function into d by dx of function minus, this is also in which form? Sine of function. Differentiation of sine function is what? Cos function into d by dx of function x minus y is equal to 0. Now differentiate the functions x plus y, x minus y. Cos of x plus y into differentiation of x is 1 plus differentiation of y is dy by dx, right? Minus, keep this cos of x minus y as it is, into differentiation of x 1, differentiation of y is dy by dx is equal to 0. Okay. We need to separate dy by dx term. How has to be separated? See, it is bracket. Dy by dx is inside the bracket. Then it means we have to remove the bracket. How it is removed? Just by multiplying this for both the terms inside the bracket. Multiply cos of x plus y into 1. Cos of x plus y into 1 is cos of x plus y. Plus cos of x plus y into dy by dx, that is cos of x plus y into dy by dx. Follow the same procedure here also. Minus into plus minus 1 into cos of x minus y. Minus into minus plus cos of x minus y into dy by dx. Cos of x minus y into dy by dx is equal to 0. Now we got all individual terms, right? Keep dy by dx term at the left side and others to right side. In underlined terms, we have dy by dx. I am taking dy by dx common. So what is remaining here? Plus cos of x plus y plus cos of x minus y is equal to what? Is equal to this first term and the third term. They don't have dy by dx, therefore they are transferred to the right side. Minus cos of x plus y. If it is taken to right side, it becomes plus cos of x minus y, or dy by dx is equal to, right first the right hand side term, I am writing positive term first, that is cos of x minus y minus cos of x plus y divided by this one, cos of x plus y plus cos of x minus y. This is the answer, right? x tan y plus y tan x is equal to 0. See, this function is having two terms. Both are in product of x and y terms. The first term x into tan y, second term plus y into tan x. On differentiating, we have to use product rule for both the terms because they are in what? Product of two terms. X into tan y, y into tan x. On differentiating, the first term is x into tan y. First one become u, second one become v. Use product rule. X into dy dx of what? Tan y plus v into tan y into dy dx of what? X plus for the second term again follow same rule, product rule. Here u is what? Y. Y into dy dx of tan x plus tan x into dy dx of y is equal to 0. Both the terms are taken in product form. Now, wherever we have dy dx, you differentiate it. Differentiation of tan y is what? Secant square y into dy by dx plus keep tan y as it is. Differentiation of x is what? 1 plus keep y as it is. Differentiation of tan x, it is secant square x plus keep tan x as it is. Differentiation of y is dy by dx is equal to 0. See, there are two terms having dy by dx in which take dy by dx common. If I take dy by dx common, what is left out here? X into secant square y plus here tan x is equal to, these two terms are having no dy by dx term, therefore transfer it. Minus tan y minus y into secant square x. Then write for dy by dx. Therefore dy by dx is minus tan y minus y into secant square x divided by x into secant square y plus tan x. We can do different problems in implicit functions. Root of xy is equal to x square plus y square. It is root of function, correct? For root of function, 1 by 2 root of function into d by dx of function. For root x, it is 1 by 2 root x, correct? For root function, it is 1 by 2 root function into d by dx of function is equal to, for x square 2x plus for y square 2y into dy by dx. Then 1 by 2 root of xy. How to differentiate this? X into y, product rule, correct? U v x into d by dx of y plus y into d by dx of x. Take the terms at right side as it is because differentiation part is over at the right side. Differentiate x and y separately and this has to be multiplied. I am multiplying this, see, 1 by 2 root of xy into this term, x into differentiation of y is what? Dy by dx. Plus multiply this, that is 1 by 2 root of xy into y into differentiation of x is 1 is equal to 2x plus 2y into dy by dx. Now collect dy by dx terms together, that is x divided by 2 root of xy into dy by dx, correct? Next, this dy by dx term, it has to be taken to what? Left side. It becomes minus 2y into dy by dx is equal to 2x. Here we don't have dy by dx. If it comes to the right side, it becomes what? Minus 1 into 1 y divided by 2 root of x y. Now take dy by dx common, x divided by 2 root of xy minus 2y is equal to 2x minus y divided by 2 root of xy, or dy by dx is equal to, first write the right hand side term, 2x minus y divided by 2 root of xy whole divided by this x by 2 root of xy minus 2y. Okay. Now I am taking important problem, y is equal to root of sin x plus root of sin x plus root of sin x plus and so on up to infinity. Find dy by dx. By looking this problem, it won't be appears in the implicit form, correct? So y is equal to this thing. It is right hand side term is in x only, correct? So we cannot differentiate it directly. Why? See, function is in what? Root of sin x plus root of sin x up to infinite times. If I go according to chain rule, I has to be differentiated for infinite times. It is not possible. So what to do? Just you simplify first before differentiating. You simplify it, make it into simple form. How? Just square on both sides. On squaring, it becomes what? Y square is equal to, this root get cancelled. The whole root is this one. That get cancelled because on squaring y square, this root square. Square root get cancelled. What is remaining? Sin x plus root of 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 sin x up to infinity. See, what is y? Y is root of sin x plus root of sin x up to infinity. See this part, it is of y. Y, root of sin x plus root of sin x up to infinity can be taken as what? It can be taken as y, right? Y square is equal to sin x plus y. What is y? Y is root of sin x plus root of sin x up to infinity. Now it become what? Implicit function, right? Differentiate on both sides. Differentiate on both sides. For y square, it is 2y into dy by dx. For sin x, it is cos x. Plus for y, it is dy by dx. Take dy by dx terms together. 2y dy by dx. If it is taken to this side, it becomes what? Minus dy by dx is equal to cos x. Take dy by dx common, that is 2y minus 1 is equal to cos x. Hence dy by dx become what? Cos x whole divided by 2y minus 1. So this is the answer. It is given infinite times, but if you go according to chain rule, so it cannot be differentiated because of infinity. So we need to simplify this on squaring both sides. It reduces to simple form, then go for differentiation, right? log of y is equal to log of x plus y. Log y is equal to log of x plus y. So differentiate on both sides. Differentiate on both sides. For log y, it is 1 by y into dy by dx is equal to, differentiate this, it is log of function, 1 by function, correct? 1 by function into d by dx of function, or 1 by y into dy by dx is equal to, keep this as it is, 1 by x plus y into differentiating x plus y. Differentiation of x is what? 1. Differentiation of y is what? Dy by dx. Then we need to separate the dy by dx term. One is already at left side. At the right side, it is in bracket, correct? We need to remove the bracket. How? By multiplying it with this factor. 1 into 1 by x plus y plus 1 by x plus y into into dy by dx. Take dy by dx term together, 1 by y into dy by dx minus 1 by x plus y into dy by dx is equal to, retain this term at right side, 1 by x plus y. Take dy by dx common, that is 1 by y minus 1 by x plus y is equal to 1 by x plus y. Or if I reduce it to dy by dx, it becomes what? 1 by x plus y all divided by 1 by y minus 1 by x plus y. If you need to simplify further, we have to take LCM at the denominator. See, 1 by x plus y. What is LCM at denominator? Y into x plus y. Then this becomes what? 1 into x plus y minus 1 into y is y. Now x plus y get cancelled. This y goes to numerator. Finally it becomes what? Y divided by x. Y cancel. This whole thing, 1 by x plus y, this cancel. So 1 is remaining at the numerator. Here 1 by y is, sorry, x divided by y is at the denominator. This x, y goes to numerator. So y divided by x is final answer. Right? You can do it different types of problems on implicit function. Right? So in this class, we discussed the derivative of hyperbolic functions and how the hyperbolic functions are used in the rules of differentiation and also in chain rule. Next, we got an idea of implicit function and their derivative. Okay, if you know this difference, definitely it will be very easy to get derivative of implicit function, right? So with this, I am concluding my today's class. Thank you. Do you have any questions? Please raise your question.